My name is Kelly Paffel, Technical Manager for Envino Engineering LLC, located in Tampa, Florida. We are an engineering firm specifically for steam and condensate systems, and we're domestic and international. Steam system engineering. Types of steam and terminology. This is a part 2 of a 3-segment presentation. And today I want to talk about flash steam, steam quality, and filtered steam. Types of steam and terminology. First one we want to talk about is flash steam. Flash steam, higher pressure and higher temperature condensate is discharged into a lower pressure condensate system. Condensate will be at the same pressure and temperature as the steam in the process, which is shown here in picture 2. So if we have 100 psi, 338 degrees Fahrenheit, steam comes into the process, latent energy is released, and condenses down into condensate at P2. This temperature here will be the same as the pressure and temperature in the process. When the condensates pass through the drain device, control valve, or steam trap, it sees a lower pressure here in the return system. The higher temperature condensate cannot exist at the lower pressure, so it has to get its temperature down to the lower pressure saturation temperature correlation. And how it does do this is take a percentage of liquid, change the state from a liquid to a vapor, or what is classified as flash steam. Again, condensate discharges in a lower pressure system return line. The higher temperature condensate cannot exist at the lower pressure, therefore the additional sensible energy is released into latent heat of vaporization, or what we call flash steam. Here's an example of a steam trap that's discharging to atmosphere, and the steam trap is operating at 150 psi, 366 degrees. Flash steam is no different than utility steam, which we talked about in part 1. It has the energy and the steam quality. Flash steam describes how the steam is formed from the flashing process. Always reused in different processes or systems. Example is a flash tank system that's located in this picture. So this is the flash steam. The condensate and the flash is coming in here, and we take the flash up here. And this happens to be a thermal compressor system where we take the steam at low pressure, thermal compressor back up to a higher pressure. The next term I want to talk about is steam quality. And so many times people talk about this as wet steam. You know, they say, I have wet steam. Remember, saturated steam is dry and visible. Steam quality, no liquid entrainment. Correct amount of latent and sensible energy. Wet steam really means poor steam quality. So when somebody says, I have wet steam, they're really saying, I have poor steam quality. Steam quality, 0 equals 100% liquid condensate, while steam quality of 100 indicates 100% steam quality. Here's an example of a steam quality, how we can check. Just take a valve on the steam line, open it to atmosphere. Remember, saturated steam is dry and visible gas you cannot see. So you're looking at the discharge right here. It's visible. It's nice. So it tells me that we have pretty good steam quality in the system. Now here's an example of poor steam quality. As you can see, the condensate, the vapor is extremely visible, which is an indication of very poor steam quality. This can have many negative effects on the process and the steam system. So therefore, we want to achieve 100% steam quality, of course, measure steam quality is really measured by a calorimeter. But if you do a pressure reduction system, the thing is that we know the upstream pressure and we know the downstream pressure. And anytime you go through a pressure reduction, you'll pick up superheat. So we have an accurate temperature measurement downstream, and we go to our superheat tables, and we know the percentage of superheat that we'll pick up. Then by adding this temperature device in there, and if we achieve that superheat, then we have 100% steam quality. If we don't achieve that superheat, then we have less than 100% steam quality. So anytime you're installing a pressure reducing station, always add the measurement devices, pressure and temperature, and you really have a in-plant calorimeter. One fact to remember, steam leaving the boiler is really above 99% steam quality. Steam quality is graded by poorly managed steam systems. The next one I want to talk about is filtered steam. And filtered steam is steam that's been mechanically filtered by several devices. Utility steam prepared by removing any liquid entrainment and corrosion particles. The thing is that no matter how well we treat the steam system, we will have corrosion inside the piping, and there'll be some corrosion particles coming down into the system, and we want to be able to remove that. Filter steam is used for applications improving steam quality and process applications, sterilization, autoclaves. Any contamination or liquids condensate can negatively affect the final process. This here happens to be a mechanical coalescing type separator, which will bring a poor steam quality back up to at least 98% or higher. Very, very efficient. Utility steam can be prepared by the following filtration: strainer, as I showed in the previous slide, standard centrifugal separator, coalescing separator, and a standard steam filter. Remember, this is a mechanical coalescing or mechanical separator. Mechanical separators are flow dependent. So you have to be sure you're up at the maximum flow through this to make this device perform. The previous device was a mechanical coalescing separator, which is not flow dependent. So you should know the difference between the two devices. Steam filtration or separator must be capable of removing particle size as dictated by the company standards or governing rules or regulations. Example, hospital sterilizers must comply with ANSI/AAMI-ST. Steam is filtered and has been through a separation. All downstream steam components and piping or tubing should be stainless steel. And that's a best practice when we do filtration and separation. This concludes our section 2 of our 3 segments. And again, we're here to be your partners in steam system assessments, engineering, steam balance, steam system performance training, to give people knowledge of steam systems and long-term upgrade process changes, improve reliability or safety. And our contact information is right here, so please contact us if you have any questions whatsoever regarding steam systems. Have a great day.